Hi guys, you okay? Can you guys see the PowerPoint on the screen?
Yeah.
Okay, so we're just going to, hello Marco. Hello. Good. We're just going to recap what we've been doing over the last few weeks, okay? Anytime you guys are stuck or you feel that you have not done anything, have not done what we've done here in the PowerPoint, or you need some extra help, just tell me. You can talk to me and then we'll go over it, okay? Okay. So if we go down, we can see that we've done graphs over the last few weeks. Have you done graphs in school, Marco?
I think so, yeah.
Yeah? Y equals mx plus c?
Yeah.
Okay,
Yeah.
excellent. So there's coordinates. The 3 represents a coordinate. The 5 represents a coordinate. Which coordinate is this? Is this x or y? X, exactly. A graph has 2 parts. An x-axis, which is a straight line going vertically downwards. Sorry, which is the line going across. And the y-axis, which is the line going up and down. Does that make sense?
Yeah.
Okay. So if we carry on, these x and y coordinates, when we plot them on a graph, they can be plotted using an equation. Let's have a look. Imagine you've got an equation, y equals 3x plus 4, yeah? Can you guys see it now? Okay.
Yeah.
What I can do, I can make a table of x values and y values. And on there, if I put x equals 1, 2, 3, 4, for example, you don't have to copy this, it's just a recap. I can then put these numbers into the equation. So where x is 1, I can put it into here. What's 3 times 1? It's going to be 3, right? Plus 4 is?
7.
7, excellent. If I do the next one, I put 2 into there. 3 times 2 is 6, plus 4 is 10. If I put 3 into there, 3 times 3 is 9, plus 4, 13, you see? What I can then do, I can say these are coordinates. So I get 1 and 7. Because an x value is always the first thing, and a y value is always the second thing. We always put our x value as the first coordinate, and our y value as the second. Does that make sense?
Yeah.
Okay. So I've got this coordinate. I've got 2 and 10, my second coordinate. I've got 3 and 13 as my third coordinate, and so on and so forth. What I can then do with these coordinates is interesting. What I can do with these coordinates over here, I'm circling, I can put them into a graph. And if I have a graph of it, I can do this. So let's have an x-axis there and a y-axis there.
Oh, and plot them.
Yeah, you can plot them exactly. So when x is 1, y is 7. So we've got here 1 and 7, as you can see from there. You guys see that?
Yeah.
And then 2 and 10. So 2 and 10 will be somewhere there. So I've got 2 and 10, again, from this over here. And then I've got 3 and 13. So 3 and 13 might be over here. And what I can do with that, I can draw a line going through it. You see? You guys see that?
Yeah.
So
Yeah.
just to remember, an equation can be turned into a graph. I've taken this equation and I've turned it into a graph. How have I done that? There's different x values on the graph. The x values are going to be here. 1, 2, 3, 4. What the equation allows you to do, it allows you to find out what the y value is for a particular x value. Yeah? So an equation that looks like this can directly be turned into a straight line graph. Does that make sense?
I say you can do that on a calculator as well.
You can work it out on a calculator. There's something called a graphical calculator, which is a very good point, Hazefa. But in an exam, they want you to do it on paper. Okay?
Ooh.
All right. You guys all cool with that?
Yeah.
Marco?
Yeah.
Okay. So
Okay.
this equation that we're looking at, let me just, it depends, a bit funny. Yeah. Y equals something times x plus another number. It might be y equals 2x plus 4. That, if any equation, for example, this one, yeah, matches this format over here that you can see at the bottom, we have an equation of a straight line. Do you guys remember that?
Yeah.
Everyone understands what I'm saying, yeah?
Yeah.
Okay. So on an equation of a straight line, this is just a recap. We're going to recap for 10 minutes because we're going to make sure we remember everything. On an equation of a straight line, these things mean something. What does the m over here mean? What is it referring to?
A number.
What number, but?
The gradient.
Gradient, yeah? And what do we mean when we say gradient? How steep your line is, yeah?
Angle of the line.
Yeah.
Yes, exactly, angle of the line. If I have a graph and I have a line like this, that's got a gradient that's lower than a line like this. because here m might only be 2. Here m might be 4. So as the value of m increases, whatever this value of m that there is increases, the line gets steeper. Do you guys see that?
Yeah.
This number at the end, what's that known as?
Y-intercept.
The y-intercept.
Yeah.
So this, yeah, exactly. So if you guys remember, those of you who've been coming to lesson, this is known as your y-intercept or intercept, you can call it. And that is where your, if you have a graph, that is where your line crosses the y-axis. This thing I'm circling here right now. So in this case, this 4 means my line crosses the axis at y equals 4. Does that make sense?
Yeah.
Roland? Roland? Not Roland, sorry, Marco? Marco?
Yeah.
Any questions on that? Marco?
No.
No? Okay. Just to remind you what we've done, this is an equation, y equals 2x plus 5. I might have a table on which I put the values. They'll test you in exams on this. They'll give you the x values, as you can see. And what you want to do is work out the y values, yeah? You're not going to do that now because you've done it before. And then you can put the y values in there. Everyone know how to do that?
Yeah.
Excellent. Once you put the y values in there, you can make a graph of it, as you can see over here. And then you can draw a straight line. Cool?
Yeah.
This is everything we've learned so far. We know on this straight line, this part here is going to be called your y-intercept. In this case, the y-intercept is 1, 2, 3, 4, 5. Same as this number here, 5. The intercept number is always the same as where the line crosses the y-axis. The y-axis is this straight line over here. Everyone cool with that?
Yeah.
Yeah.
Excellent. All right, so now, gradients and intercepts, we've done all of that. We said, look, if your line slopes up like this, you have what we call a positive gradient. What about if your line's flat?
Constant.
Neutral.
Neutral or 0, yeah? 0 gradient. If your line slopes downwards, what about if your line slopes downwards?
Negative.
Negative gradient. So a negative gradient is very interesting. We're going to look at this in a minute. Okay, so you might have, let me give you an example. I'm going to go back to the whiteboard. If I just, again, this is stuff you guys know, but I think it's very important to recap. You might have 2 equations, yeah? You might have an equation that looks like y equals 3x plus 4, and then you might have y equals minus 3x plus 4. If I was to draw them on a graph, and you guys can think about it as you do it with me, you don't have to write it down yet. Again, this is still a relaxed lesson today. If you look at this line here, 3x plus 4, it'll be something that goes up, and it'll cross at y equals 4. Yeah, because it's got the gradient here is positive. If you look at y equals minus 3x plus 4, now this is going to, exactly, it's going to go down. And it's going to pass through 4 as well, but because the gradient's minus, it's going to be this line over here. Clear, guys?
Yeah.
Yeah.
Okay, excellent. So good stuff. This is the most important stuff to know about in graphs: negative gradient, positive gradient, how it works. Can we see the PowerPoint?
Yeah.
Yeah.
Okay, I'll always ask you guys when I change screens, because sometimes the screen's not shown clearly. Now, if you're given 2 points on the graph, watch this carefully just to remember. You're given a straight line, as you can see over here, yeah? My mouse is hovering over it just to show you where the line is. You might have x1 and y1, which is a point on the line somewhere, some coordinate, and x2 and y2, some other coordinate. You guys see that?
Yeah.
Yeah.
Okay. How do I work out the gradient? There's a formula I can use here to work out the gradient.
Is it y1 over minus 2? No, y1 minus y2 over x1 minus x2.
Yeah.
Very, very close. The gradient. Sorry, go on. Yes. What it is, we do this equation here. I'm going to show you. So as you can see, look at the line carefully. You've got to find the height of the. You see this? You can turn it into a triangle. This thing over here, you make a small triangle out of it first of all. As you can see, the triangle started. Okay. Once you make the triangle, the top of it is going to be called the y2 and the x2, as you can see over here. So that, and the bottom of it is going to be called the x1 and the y1. I want to find this height. I want to find this height over here. For me to find that height, I'm going to do y2 take away y1. So there. If I want to find it, and I need to find this length. If I want to find this length, it's x2 take away x1. And I get this equation here. the gradient is y2 minus y1 over x2 minus x1. Okay? Does that make sense?
Yeah.
Yeah.
Yeah? Have you seen that before, Marco?
Yeah, I've done that.
You done that? Okay, good. So it's a good recap. Just remember, that's the way you get your gradient. If you know any two coordinates on a line, you can get your gradient by using this formula. Just to remind you, I'm going to show you an example on the whiteboard. Can we all see the whiteboard?
Yeah.
Yeah.
Excellent. So let's say I've got a graph here. Oh, look, a straight line. Amazing. Okay, well, kind of. And I've got coordinates, and I know this one and this one. And let's say that coordinate here is 4 and 3. And this coordinate here is 2 and 1.
Yeah.
Obviously now, we know this is x2 and y2. And this is x1 and y1. So what we do, y2 minus y1 over x2 minus x1 is going to give us our gradient, yeah? So how do we do that? We do 3 minus 1, so that equals to 3 minus 1 over 4 minus 2. Do you guys agree?
Yeah.
Okay, so that's going to be 2 over 2, because 3 minus 1 is 2, 4 minus 2 is 2. So our gradient is going to be 1. So y equals 1x plus c. Get that, guys?
Yeah.
Yeah.
Okay. Quick question now. You know, in an equation for a straight line, you need to know the gradient, and you also need to know the value of c. How do we work the value of c out here?
You go on
You
the line.
substitute the point values.
You find the x.
Yes, good, good, good. So you substitute one set of values into the equation. Let's say I substitute this set of values into the equation here. What happens is I'll get y equals 1, because that's the gradient, times x. X is going to be here 4. 1 times 4, I'll put the multiplying sign as a bracket, plus c. Now the y was obviously the 3.
Yeah.
Yeah, so 3 equals 4 plus c. So what's c going to become? C equals 3 minus 4. In real life, this graph should be c equals minus 1.
Minus 1. Yeah.
Right? So this equation will become now y equals 1x, which is just x minus 1. Do you guys see that?
Yeah.
Yeah.
So this is all the stuff we learned. We're recapping because we haven't had school for a while. It's important to recap. And you guys are doing very well because you remember it. It gives me confidence that you're going to do well in exams when it comes up, God willing. But for now, let's carry on. So we know the equation of a straight line. We know y equals mx plus c. We've done all of this stuff. Again, all of this stuff, you see this lesson, it's going to be recorded. And I'm going to put it on YouTube so you guys can see on YouTube the lesson you've done. Hopefully the recording works today. If it doesn't, all future lessons will be recorded. The PowerPoints I'm using, I put them on Google Classroom. So after you've done a lesson, you can go on the PowerPoints and practice. Does that make sense?
Yeah.
Okay, good.
Yeah.
So we've looked at the equation of a straight line. I want to look at one more thing before we carry on, which is the following. I'm going to get my whiteboard back up because I feel it's a better way to look at it. Let's get the whiteboard back up. Can anyone guess what we're looking at next here?
Yeah.
What? Anyone guess?
What was that?
Can anyone guess what we're going to look at next? No?
Quadratic graphs.
You're close. We're coming to that. We're just going to recap this thing. Perpendicular,
Oh yeah.
yeah,
Okay.
and parallel lines. And parallel lines, yeah. Now we've done this before. You can take notes if you want. Parallel lines. So here, here, here. Okay. Now there's two situations that can occur. Two situations in life. You might have a graph. Oh, my straight line is terrible. I need to get a line. I need to get a line drawing tool to do that next time. Oof. Looks like my sister's straight lines. 1 second. But this line here, yeah, you got two lines on it, and they're what we call this is not parallel at all. If two lines have the same angle roughly, what are they called?
Parallel.
Parallel, yeah, because they'll never touch each other. Yeah, so you have the parallel situation, parallel. And then you have this situation here, which is the more difficult one, which we're going to look at. You've got two lines and they cross each other. What do you call that?
Horizontal.
Perpendicular, yeah?
Oh, yeah. Perpendicular.
Okay.
Yeah.
Now, if two lines are parallel, what does it mean about their gradients?
They're the same.
Same value of m. But when two lines are perpendicular, we have an issue here. So we're going to talk about this in more detail. Marco, have you done perpendicular lines?
No.
Okay, so let's do a lesson on that now, because we're going to recap it, yeah? Because I think everyone needs some reminders of that. Is that clear?
Yeah.
Okay, so let's write some notes down. Okay. Right. When two lines are parallel, as we've just said, their gradient will be the same. Their gradient is identical. Can you understand my handwriting, guys?
Yeah.
Okay.
Should we write this down?
You can if you need to. If you think it will help you to rewrite it, you can, yeah? I think you've written it before, but it's just a recap because it's so easy. This is so easy to forget. And then the next bit is going to be the following. We're going to do a lot of the complicated maths after this as well. When two lines are perpendicular, their gradients. Someone finish this sentence off for me. Their gradients will do what?
90 degrees. I mean, it's what's it called?
God, you know it. I know you know it.
I know it, but I can't remember the words.
No problem. We'll
It times to
multiply.
-1.
Yes, we'll multiply to.
M1
-1.
equals -1.
Yes. Can everyone see the exam paper I put on?
Yeah.
Yeah. Okay. So some of you have seen this already. Let me go back up. Okay. So let me push this up a bit more. Now here it says, I want you to do two things here. So I want you to answer this question, number 3, yeah? At the same time, I want you to write the equation of a line that is perpendicular to it.
Okay.
Clear?
Question 3.
Question 3, yeah. Do 2 parts. Write the equation of the line that is parallel to y equals 4x minus 3. Don't worry if you don't get it, I'll explain in a minute. And write the equation of a line that is perpendicular to y equals 4x minus 3. So whichever one you can do. Do the parallel one, do the perpendicular one. And so I'll add the second bit on. I'll say, look, part B of this is going to be, right, my H is gone. Write the equation of the perpendicular line. So I'm going to learn through this.
Is it for the second one?
Yeah.
-1/4.
Yes. Okay. Let's go through it. Are you guys ready to go through it with me?
Yeah.
Yeah, let's do it. So look, we had this equation here. Okay. Y equals, oopsie daisy, my handwriting again. Let me just make sure I get it right. I like to write neat. Y equals 4x minus 3. Agree with that?
Yeah.
Okay. This is obviously going to make a line on a graph. So if I draw a line on a graph, now I'm just drawing a line to teach you guys how it works. You don't have to draw a line, but it's good to do it. 4x, is this gradient here positive or negative, Marco?
Positive.
So it's going to be a line that goes up, right?
Yeah.
Now this intercept here is -3. So where is this line going to cross this thing? At -3. So it's going to be something like, it's going to be something like that, yeah? And that value there is going to be -3. Agree, guys?
Yeah.
Okay. If a line's parallel to it, should it have, imagine you have a parallel line to this, yeah?
Yeah.
Imagine the gradient of the parallel line is a bit, imagine you have another line. Let's say another line. Let's not say parallel yet. Imagine you have another line and the gradient is not the same. This one's a bit steeper. What's going to happen eventually?
They're going to meet.
They're going to meet. So is it parallel then?
No.
No.
Perpendicular.
It's going to cross it somewhere. It's not going to be perpendicular yet. Perpendicular is when it meets this. It's going to cross. So this second line that's parallel, what kind of gradient should it have?
The same gradient.
Same gradient. Does that make sense, Marco? The second line that's parallel has to have the same steepness as the first line. Clear? Yeah, Marco?
Yeah.
Yes? Okay.
Yeah, I got that.
You got that, yeah? So it becomes y equals 4x. And it might be intercepting somewhere else. It might be at -5. So it could be 4x minus 5. It could also be y equals 4x plus 10. So it might be over here and intercepting at 10. Do you guys see what happens? Whenever two lines are parallel, they have the same gradient, but they'll have different intercepts. Clear?
Yeah.
Okay, everyone okay there? Now, I want to draw a perpendicular line. So let's go back to our original line, our original friend we looked at, and let's draw a perpendicular line to it. This is your perpendicular line. I know it's going to have an equation of y equals mx plus c, but I don't know what my m value is. I don't know what my gradient is. What was the rule we looked at earlier? The rule earlier said if two lines are perpendicular, they cross like this, then m1 times m2 should equal to minus 1. What is m1 over here? Our first gradient is 4. So 4 times m2, that's our second gradient, we call it m2. 4 times m2 should equal to minus 1. Now, what do? We want to find the gradient m2. We divide this side by 4 to get rid of it. And we divide that side by 4. So m2 becomes minus a quarter. Does that make sense, Marco?
Yeah.
Okay, so our gradient of our second line is going to be y equals minus 1 over 4 x plus c. And they haven't asked us to work out c, so we don't need to do that. They just wanted to work out, we just wanted to work out the gradient of the second line. Is that clear?
Yeah.
Yeah.
Do you understand now, Marco, how to work out the gradient of a perpendicular line?
Yeah.
Okay, cool. So now that we've done that, we're going to move on. There's a lot of other stuff we covered in this topic, but if I was to cover it, recap it all today, then it will just be long, and we've done it before. And if you guys need help with it in the future, we'll do it again. So we're going to move on to the second bit of graphs, which we haven't done, which is curved graphs. Yeah, graphs that don't follow a straight line, but they have some type of curve in them. Yeah, some graph, squiggly graphs. Ready, guys?
Yeah.
Okay, let's start. So this again is another one that's tested in exams very, very frequently, and one that people make mistakes. I want to go all the way back. There's a lot of stuff. Write down the title, guys. Graphs of nonlinear functions. Okay, once you've written that down, let's look at the objectives of the lesson we're going to do over the next 1-2 weeks. We're going to do inequalities and other stuff as well, but we have to understand this first. We're going to look at plotting curved graphs, and you guys have done some exercises with me to do regarding that in class. We've done it on an exam paper, if you guys remember. If you remember this question here, just put it up. Can everyone, no, not that one. Can everyone see the exam paper?
Yeah.
Remember the question a few weeks ago, we plotted a graph?
Yeah.
So, we're looking at 4 things, or 5-6 things. Plotting curved graphs, how to plot a curved graph. Graphs of important nonlinear functions. Sometimes you have an equation which doesn't give you a straight line. We're going to look at that. Look at this. Nonlinear functions, nonlinear graphs. If a graph is not a straight line, it will have an equation. And the equations might look something like these. Y equals x squared plus 1. Y equals 7x cubed minus 3x. Y equals 2x plus x to the power of 8. Y equals 5 over x minus 2. Yeah. What is it? Y equals 3 plus 2 to the power of x. You can see here where my arrow is pointing, 2 to the power of x. What is it about these equations that's different to the equations we've looked at for straight line graphs?
They have a power.
They have a power, yeah? They all have a power. As soon as the x in your equation has a power, your graph won't be straight anymore. That will always happen. Whenever you have a power next to the x, like a power that's not 1, in this example, the power is 2. Here, the power is 3. Here, the power is 8. If you have a power that's not 1, your graph will not be a straight line anymore. Clear?
Yeah.
Here we have the
What
x.
about the?
This one?
Yeah.
Good question. Now here, we'll have a power of x. What happens here, x has a power of minus 1. And we'll talk about why that is later, but x here will have a power that's not 1 either. Does that make sense? Because remember, when you have something underneath in an equation, Josefa, What happens when
Yeah.
you take it to the top? What happens to the index? The index goes to -1. Do you remember that?
Yeah.
Yeah. So here, even the x doesn't have a power, which we'll talk about later. Here, the x is a power, which is weird. Yeah. So it's not normal. It's not a y equals mx plus c situation. Okay. So you can plot a graph of this using a calculator, as Huzaifa mentioned earlier. Look, right there. Or we can make a graph by calculating ourselves. So what I want you guys to do is look at this equation, and I want you to fill in the table over there, just to make sure your calculations are okay, yeah? And then I want you to plot a rough graph of it on a piece of paper. Is that cool?
Yeah.
Yeah, have a go. Just to practice. Give you a few minutes. A lot of people make mistakes on this. That's why we practice again.
You have to draw the graph as well.
Yeah, just a rough graph, just to make sure you guys are getting the right idea of the graph. Just practice, even though graphs like this are very easy if you practice them a few times. Maths is all about the practice. I'm going to put the first value up. We should be getting 6. Are we getting that, guys?
Yeah.
Because when you square a minus number, it becomes positive. So I can see the shock on some of your faces. When you square the -3, it becomes 9. Then 9 minus 3 is going to be 6. That's why we're practicing this. Yeah, Marco?
Yeah.
Yeah, I saw that shock on your face. It was funny. Did you get it right the first time?
No, I put -12.
That's fine. Do you understand why it's a 6
Yeah.
now? Okay. So I'm going to put the other answers up. This is what we're getting. Once you've got that, plot a rough graph of it.
Okay.
So you can see the coordinates here that we build up by using an equation. If you notice, it's always the same pattern. You have an equation, you have a table, then you get coordinates, and then you can make a graph. What this shows us is every graph that you find in the world has some type of equation behind it that made it. Okay, once you do that, we can plot the graph. And we plot it kind of like this. Notice one thing here. Where does this graph cross the y-axis? At what number?
0.
It's minus. You see this? 3, yeah? It crosses the x-axis at 0. X is 0 here. But if I want to see where it touches the y-axis, this y-axis, this straight line here, it crosses or touches the y-axis at -3. If you go back to the equation here that you can see with my arrow, top left hand of the screen, what's this number here? -3. So the intercept in the equation is similar to how we looked at before. The number at the end is the intercept. Does that make sense, guys? Yeah, Hamza?
Yeah.
Okay. Hamza, you okay there? Hamza? Yeah, okay.
Yeah.
Okay, excellent. All right, so yeah, as soon as you reply, you can mute it again if you want. This is called a parabola, okay? A curved shape. It's known as a parabola. And many people use this type of maths. If you're a sniper in the army, for example, and you shoot a bullet, your bullet falls down to the ground in a parabolic path. Yeah, it follows a curved path. So they use equations to work out how far the bullet's going to travel, which is what you'll learn that in physics one day, hopefully, but it's just something extra.
We have to write.
Sorry?
You have to write that.
You can write down, just write down next to that this is a parabola, so you know. So that's an x squared graph. Now we're going to practice another one, which is very important, called an x cubed graph. Okay? Watch. I'm going to put it up. We're going to do the same thing.
Is that
Now,
the one where the line ends up as an S?
Yes, basically, yeah. And we're going to look at that. So what I want you to do, I want you to look at this equation. Good point, Huzaifa. Make a table for it, x3 minus 7x plus 2, and plot the values of x between -3 and 3. You guys know what you're doing?
Yeah.
Okay, go. Zach, you okay?
Yeah.
Good. Well done. I like you. You guys are working very well, and you have a lot of good manners as well. You're turning your microphones off so no one hears noise. It's nice to see that. So Marco, are they giving you work from school?
Yeah.
Yeah.
But
Did they give you lessons online as well in school?
No.
Okay, no problem. Is anyone stuck?
No.
No, good. Gonna give you guys a few more minutes. If you finished it, let me know.
Yeah, I finished.
Okay. Yeah, go on. So look at the answers. The first one, when x equals -3, y will equal -4. When x equals -2, y equals 8. When x equals -1, I'm going to put the answer up now, y equals 8. Again, interesting. When x equals 0, y equals 2. When x equals 1, y equals -4. When x equals 2, y equals -4. When x equals 3, y equals 8. Now, are you guys getting the right answers so far?
Yeah.
Yeah?
Yeah.
That's good. What you can do is just copy this x and y values down. Don't copy the whole table. Just get the right y values down, because if you've been doing it right so far, then it means you can do all of them right probably. And then plot a small graph of it. So your next job, after you get the answers down, is to plot a graph. And as Hussein said, you should get a squiggly looking graph, like an S-shaped graph. All right, ready guys?
Yeah.
Yeah.
So the graph should look something like this. Yeah?
Yeah.
So good. What we're noticing is the following things. I'm going to write some stuff that you can draw your graph out. I'll give you a minute to just write your graph out, a rough version of it. We're going to just talk about this a little bit. These patterns. What we find is the following. We find this when we look at this. I'm going to bring my screen up. Okay. Can you guys all see the whiteboard? Can we all see? Everyone see the whiteboard?
Yeah.
Okay. We're finding this pattern. Like, look, if you have a y equals mx plus c graph, if the x has nothing next to it, you're gonna have a nice straight line. Okay, easy. If you have a y equals something with a squared graph, you have something that looks like this or that. It will be a curve. Does that make sense, guys?
Yeah.
If you have a y equals an x with some type of cube next to it, then you're going to have a graph that looks something like that. So just remember that if you have x with no power next to it, like this, you're going to get a straight line, y equals mx plus c. If your x has a power of 2 next to it, it can be a line that curves up, a parabola that curves up, or a parabola that curves down. If your equation has a cubed next to it, then it will always be like a s that's been turned on its side. Do you guys see that? Does that make sense, Marco?
Yeah.
Marco?
Yeah.
Yeah, okay. So what we're learning in GCSE physics, GCSE maths, is that it's very important to understand these things, what these 3 different types of graph look like. If they ask you in an exam, if there's just an x on the graph, what will it be? It'd be like straight line. If there's an x squared, parabola. If there's an x cubed, it's going to be like an S shape or an M shape even, some people say. Yeah. So the power next to the x influences the shape of the graph. Important. Let's move on to greener territory. Okay, now graphs of important nonlinear functions. If you write this down as a subheading. So nonlinear functions means a graph without a straight line, an x squared graph, an x cubed graph, a graph where x is at the bottom being divided into something. These are all nonlinear functions. They don't follow a line. They don't follow the pattern of a line. So the thing is this, a quadratic function always contains a term in x squared. What this means, a quadratic function is something that contains x squared in it. That's an easy way to look at it. They're going to make it more complicated than it needs to be. Anything with an x squared in it will look like this. Yeah, we just talked about that. So you can say a quadratic function will always give you a parabola. You can write that down. You don't have to write example. You don't have to draw these examples. You can if you want to. Again, this PowerPoint is on Google Classroom, so you can look at it again. I'm going to show you something in a second. Look at what happens here. Y equals x squared, just a normal parabola, a normal curve. Y equals x squared minus 3x. Look what the 3x does to it. Look what this extra thing does to it. It makes the graph go down here for some reason, which we'll talk about sometime. And look at this one, y equals minus 3x squared. If there's a minus next to the x squared, it flips it upside down. Can you guys see that? Yeah? Okay.
Yeah.
So that's important to know. A quadratic function contains x squared in it. These are all quadratics. Why? They all contain an x squared somewhere. Look at the first one, x squared. Second one, there's an x squared here. Third one, an x squared. Even though there's a minus 3 next to it, the x still has a squared there. The characteristic shape of a quadratic function is called a parabola. In English, these shapes are known as parabolas. Okay. A cubic function always contains the term x cubed. So the x cubed function is known as a cubic function. You can write that down, yeah? X cubed equals cubic. Now the cubic function, like for example this one where my mouse is circling, is cubic. It's got an x cubed in it. It also might have an x squared in it. But we call it a cubic because the x cubed's in there. So look at these examples of cubic functions. Always looks like an S. They're called cubic because they all have an x cubed term in them, as you can see. Yeah. All right. So we know that. Those are important things to know. These are the ingredients of graphs, part 2, which we're doing now. Right. So the next one, we call it a reciprocal function. A reciprocal function always contains a fraction with the term x in the denominator. That means x is at the bottom. So look, y equals 3 over x, y equals 1 over x, y equals minus 4 over x. A reciprocal function always has like a shape, half of a C. You look at this over here, this is half of a C. If you carry it on, you'll make a C. It can be half of a C the right way around, or half of a C upside down. Again, half of a C. Right way around, or upside down. Does that make sense, guys?
Yeah.
Yeah? Okay. So this is a reciprocal function, one with x underneath. We've looked at 4 different functions. We've looked at y equals mx plus c. We've looked at y equals x squared of something. We've looked at y equals x cubed. And now we're looking at y equals something over x. Those are 4 important functions you have to know. Okay? Just to recap, remind you, I'll just write them down a little bit again. So we've looked at so far the 4 functions we've looked at y equals mx plus c, that's number 1. We've looked at y equals something with x squared, that's number 2. We've looked at something with y equals x cubed, that's number 3. And we've looked at y with something over the x. Yeah, I call it a over x here, just to give you an example. Those are the 4 functions at GCSE you need to know, yeah? 4 important functions. You need to understand all of them, which we're doing very well. You guys have understood this. You know how to draw a graph on this. You can draw graphs on this. I'm sure if I gave you a graph to draw on this, you could do that, because this one is actually easier than this one and this one to draw. We'll test that at exams later. But they're basically 4 important functions. We've looked at them today. We've got about an hour left. Do you guys want a 5-minute breather or we carry on?
Breather.
How many of you want a breather? Put your hands up. Okay, cool. 5 minutes, yeah? Let's get back in 5 minutes. Don't turn your computers off, leave them on because we'll need it, yeah?
Shakule.
Yeah, give him a quick. He's back. Thank you. All right, good. So, back in the game. Huzaifa?
Yeah.
Good man. All right. So, now the next function we've looked at so far, let me just recap what we've looked at to make sure you guys know what's going on. Onto my screen, return to meeting. I'm in the meeting now. Can you see me, guys?
Yeah.
Yeah, cool. So I'm just on my whiteboard quickly. Can you see the whiteboard?
Yep.
Okay. So what we've covered 1, 2, 3, 4 important functions, and then we had a break. I reminded you of these 4 functions before the break, just to let you know that's what we've done. And now we're going to move on to the next important function and talk about that. So we're going to talk about all of them briefly first, and then look into them in detail as time goes on. Can you see what's on the board now? Exponential?
Yeah.
Yep. Marco, you there?
Mm-hmm.
Can't see
Okay.
it. Can't see it.
You can't see it? Let me, oh, sorry. Oh, wait. Let me put it back on. Okay.
Yeah.
Yeah, everyone can see it?
Yeah.
Okay. So if you write the title down, an exponential function is a function in the form y equals ax, where a is a positive constant. So it's a number with x as your power next to it, yeah? Why is my screen? Yeah, there we go. So for example, y equals 2 to the power of x, 3 to the power of x, 0.25 to the power of x. Can you see that, Marco?
Yeah.
Excellent. So I want you guys just to copy down the definition. And this time I want you to copy down the 3 graphs as well, because these graphs are not taught very commonly. It's good to know them. I think your camera stopped working, Marco.
No, I just turned it off.
Oh, that's fine. You can keep it off if you want. So if you guys copy the 3 graphs down, just a rough version of them, notice 2 to the power of x is not as steep as 3 to the power of x. The bigger the number gets, the more steeper your gradient's getting. Yeah. And if your number is less than 1, it basically flips around. You can see this has flipped around and is not in the normal direction. Normally you have uphill, but it flips around and goes downhill if you have less than 1 as your number next to x. Now, this is a very important word. In each of these examples, the x-axis forms an asymptote. You can see what it says there, asymptote. An asymptote is where the line goes along the axis. Look, this line's going along the x-axis here. This line's going along the x-axis here. This line's going along the x-axis. So it's where your line goes along the axis but doesn't touch it. It's not meant to touch. Even though they show it touching over here, it goes along it just above it. It hovers above it. Does that make sense, guys?
Yeah.
Good. So that's what we call an asymptote, asymptotic curve.
So all of them are asymptote.
Yes, all of them are asymptotes to the x-axis. Because this
Okay.
is the x-axis, they're all not touching the x-axis, but going very close to it. Yeah. It's like when you're trying to score a goal from the corner, and then the ball travels along the goal line, but doesn't go into the goal. It's not got inside, but it's traveled along the line and then hits the post and rebounds off maybe. Happens very rarely. Okay, so once you've drawn that, we'll move on. Are you guys okay with me moving on?
Yeah.
Okay. Let me know if you want me to keep it on. I'll also upload this on Google Classroom if you miss anything.
Not yet.
Not yet?
Not yet.
Okay, cool. Take your time. We're going to do some exam questions on this hopefully today if we have time. If not, next week we'll continue with the exam questions. Ready, Zach?
Yeah.
Yeah, good. Okay. So now, those are some graphs that we've looked at, okay? The equation of a circle is something we're going to look at as well very, very soon, okay? But we're going to skip this part for now because we're going to look at this part in circles. So we're going to move on to the next bit. Using graphs to solve equations. This is probably going to be the hardest bit here. But we're going to get it done. It's going to involve something called simultaneous equations. Okay. So once you write your title, we're going to start looking at this. Any confusion, guys, just shout out, no problem. Okay. So, how do we use graphs to solve equations? Let's look at an example. It says this. Write this down. For example, and then write the question underneath it. Solve the equation 2x squared minus 5 equals 3x using graphs. So I'll write this question down. And then we'll look at how to do this. They've written it in a very complicated way, which is what you'll see in exams. That's why we're going to start like this. And then you're going to write the notes down now. So what you do here, you see you have two sides to the equation. The left-hand side, which I'm circling with my pen now, or my mouse, and the right-hand side. And they're separated by the equal sign. The first thing you do is consider the left-hand side and the right-hand side as two separate equations. What does that mean? We say this and this, we separate them into two equations. So we give this its own equation, y equals 2x squared minus 5. And we give this its own equation, y equals 3x. So write that down.
And you substitute it.
You can draw it or you can substitute it. Very, very good. We're going to look how to do that now. Once you write the two equations down, you can make two lines out of it. Why? Because look, I'm going to show you something on another graph in a second after you write it. Some of you are still writing it, so let's have a little second to let you write. Y equals 2x squared minus 5 and y equals 3x. What you're going to find here is the following. Let me bring my screen up. New share. Let's share the whiteboard. Where's my whiteboard? Yeah. You got two equations, yeah? So let's have a look. You've got y equals 2x squared minus 5 as one equation. Y equals 2x squared minus 5 as an equation. And you've got y equals 3x. What does this look like? This looks like y equals mx plus c. Agree? Because if there's a 3x and no c, it just means plus 0. So your line will pass through the axis. I will show you this in a second. So if I have a graph, if your intercept is 0, that means your line passes through 0 and you get your line there. Does that make sense?
Yeah.
Yeah? And then you have another line, y equals 2x squared minus 5. Because there's an x squared in there, what shape is my graph going to have?
It's going to be a parabola.
Parabola, good, well done. And my parabola is going to go whack, whack. And this number here, what's it going to be? Minus 5, agree? Yeah? Does that make sense, Marco?
Yeah.
Okay. Now what happens? This line crosses. They cross here and here. There's going to be some coordinates where they cross. When they're asking you to solve an equation, when they tell you to solve these equations, these two, they're just telling you to find where they cross. So when they say solve an equation, they want you to find the coordinates of where they cross, where they have the same values. Does that make sense?
Yeah.
Yeah.
Okay. So going back to our PowerPoint, we can understand now using a picture what's going on. Pictures always help. Can you guys see the PowerPoint?
Yeah.
No.
No? Let me just share it. Yeah?
Yeah.
Cool.
I need to copy this.
So, copy that. You got two equations, and they represent two things in a graph. And when we drew the graph, we can see they represent lines that cross each other. And what we're saying is that this question's asking you to solve it. What it means, it wants you to find the coordinates of where they cross. So if I press my button, it says the points where these two functions, oopsie daisy, let me go back. The points where these two functions intersect will give us the solution to the equations. So you guys maybe copy everything down that's going on in notes, so you can see exactly what we do. Okay. Okay, I think Hamza, you've copied, haven't you? Yeah. Okay. Zach, you finished?
No.
Which one you on?
Two functions.
Okay. Okay, good. So let's give you another 10 seconds with that. And then we'll move on. Sorry. Sometimes it's good that you guys take different times to copy things because it allows the people who've written it to have some time to digest it and not be overloaded as well.
Okay.
All right, cool. So you can see your graph looks something like this. I'll just drew a rough graph earlier, but it looks basically similar, doesn't it? They intersect.
Yeah.
And then look, if you drew the graph, you'd find a solution here, and you'd find a solution there. So one way you can find the answers is just by drawing the graphs neatly, and you'll see on the graph paper where they intersect, and then you're going to have your answers. Cool?
Yeah.
So your values are going to be there and in other places as well. Does that make sense? You don't have to write any of this down. It's just explaining what's going on. Clear?
Yeah.
Okay. Now, if I was to solve an equation using graphs, you know what to do. You separate the equation into two parts, a left-hand side and a right-hand side. Yeah? Sometimes what you do, I'm going to come back to later actually, because what we can do is this. You see this 3x over here? You guys think that?
Yeah.
Take it over to this side and the equation becomes like this. That can happen. You can do that as well. Then the left-hand side, you give it its own equation. I think Hamza, I think there's a bit of background noise from you. If you can just put your thing on mute. Okay?
Yeah.
Yeah. Excellent, thank you. So your left-hand side becomes this, your right-hand side becomes that. And then you can draw a graph. The line y equals 0 is the x-axis. You see this thing over here? It says y equals 0 is the x-axis. We're going to talk about why that is in a second. When you say y equals 0, what you actually mean is, let me share my other screen with you to show you what's going on. When you say this, when you say, if you said this, y equals 0, what that means is you have a graph and you have a line along this part of the graph over here. It's just a flat line. That's what y equals 0 means. Anytime you see something like y equals 0, it's this line. If you see x equals 0, it's just talking about a line over here along this side. Does that make sense, guys?
Yeah.
Okay, so when we go back to our PowerPoint, can you see the PowerPoint? Let me know. It's just 1 minute. Yeah, here's the PowerPoint. So now the line y equals 0 is the x-axis. So this means there's a line at the x-axis from this, and there's going to be another curve because this is an x squared here from this one. So what's going to happen is this. Look, we're going to have the following happening. We have the curve from the main graph equation with this one. If we drew that out, we'd get that. And we have this straight line here. And the solutions are going to be here and here. So we get that as our solutions. Does that make sense, guys?
Yeah.
Yeah? So that's all it is. If you want to draw something out and find the solutions, you do it like this. Okay? You find where things intersect. So you can, you can remember that and make a note of it as well if you want. And I'm going to put this PowerPoint, I'm going to email this PowerPoint to all of you. So you can add extra notes to your notes from there. You can leave a little space in your notes if you want to add some notes on this later. But basically, all we're saying is if you have two equations, 1 and 2, where my arrows are pointing now, you can draw them out on a graph, and wherever they intersect, you have solutions. Okay? Now, I could give you a lot of questions on this, but I won't. I'm just going to take you through examples, and then we'll do questions to the exam paper. So if they gave this to you, Marco, this question, how would you do it? What would you say first?
I would split the equations.
Yes.
I'll put x cubed on one, x cubed minus 3x on one side, and then y equals 1 on the other.
That would work. That would work really, really well. And then you draw them out, right?
Yeah.
Well done, Marco. Excellent. What you could also do, you see this 1, you could take it to this side. And here this would become y equals 0, and then this equation would be the other one. Does that make sense?
Yeah.
That you could do that too. So very, very, very good. So what Marco said was what they're doing on the board now. You can see exactly what you said, Marco, is exactly what's happening. And then when you draw the equations, y equals 1 simply means that. Yeah, y equals 0 is a line there. Y equals 1 is a line at 1. Y equals 2 will be a line at 2, and so on and so forth. And you can see, look, there's 3 intersections. 1, 2, 3. Does that make sense, Zach? Zach,
You
just
know,
look at-
you know the other way,
yeah.
when you minus the 1 and you make it to 0.
Yes.
Yeah, what do you do after that?
Then you make an equation. Let's say I minus. Let me draw it out for you. Yeah. So this is a very good question, Zach. So let's draw it out. Give me 1 second. Let me just write it down. X3 minus 3x equals 1. Okay. So Zach's question was, if we do it the other way, how do we do it? It's a very good question because we can explore it a little bit now. So I'm going to draw a new. No. Can you see my whiteboard?
Yeah.
Okay. So our question was here. X cubed, let me make it a bit neater. X cubed minus 3x equals 1, yeah? What we can do, we can take all of this to one side. We can say, look, this is the second way to do it. Second way. We take it all to one side, so it becomes x cubed minus 3x minus 1 equals 0. Then we separate that into two equations. We say this part becomes y equals, oopsie daisy, x cubed minus 3x minus 1. And this part becomes y equals 0. Agree?
Yeah.
We then put that on a graph. So now, if I just draw a graph on the left-hand side here, y equals 0, this one, will simply be a line going along here. Just going to color it in a bit to show you what it looks like. And this one, I make a table and a graph of it, and it will cross this line here at 1, 2, and 3 points. Your coordinates here, here. So your coordinates here, here, and here are your solutions. Does that make sense, Zach?
Yeah.
So that's what it is, yeah? You can use either method, they both work. Okay, and that was a very good question because it helps us all to understand what's going on. So let me make this, let me share this page now back again. All right, everyone can see the PowerPoint?
Yeah.
Excellent. So let me show you what's going on. All right, so there. They've done it slightly differently. We can do it the other way. It all works. Right, so now there's something called solving equations by trial and improvement, which we're going to do at some point. There's something called function notation, and there's something called transforming graphs. These are the next 3 parts. So let's start looking at solving equations by trial and improvement. It's called the iterative solution, but we're not going to give it that complicated name now. Just write down the title and let's move on. You guys should be masters of graphs in the next couple of weeks, inshallah. Oh. Okay, now that you've got the title, what do we mean by the solution of a graph? Let's look at this question here. The equation x cubed minus 3x equals 1 has a solution when x is approximately equal to 1.9. Find this solution to 3 decimal places. It looks complicated. I want you guys to copy the question down because it's an every time what we'll do when we learn the topic, we'll do one question together. We'll copy it down and the rest you can do normally. Have you done this before, Zayfa?
Yeah.
Yeah, are you well versed in it, you think, or?
Yeah, I'm looking alright in it.
Okay, good. It's just a recap then for you, yeah?
Yeah.
Okay. So what this actually means, I'm going to go back to my little writing application here, okay, because I want to explain to you what this means. they ask you a question like this. Let me get a new page on. No. So they ask you to find the solution. I'm going to write the question out as well. Find solution to x3 minus 3x equals 1 when x equals 1.9. When x equals 1.9. When they're saying find a solution, what they mean is they want you to find a number that you can put into x. What number can I put into x to make this equation true? If I put the number, let's have a look. So basically, what number can I put into x? Oopsie daisy, that was a bit weird. Can I put into x to make equation true? So let's look at this equation. It says x3 minus 3x.
Wait, is that 1.9?
Yeah, 1.9, yeah? Sorry, that's a good point. Thank you. It's just when I put the dot on, I don't think the computer registered it. Maybe. Equals 1. Imagine I put x equals 2. So imagine, no, let's look at another number. Imagine I put x equals 3. If I put x equals 3 in here, what happens? I'm going to get 3 to the power of 3 minus 3x equals 1. Let's check this side out. What's 3 to the power of 3? 27. Because that's 3 times 3 times 3. That's 27. Minus 3x minus 3 times 3. So minus 9. And then my equation will become like this. What happens here? 27 minus 9, what is it? 27 minus 9 is going to be 18. Does 18 equal to 1?
No.
No, so it doesn't work. Now, let's try and put another number in there. We might put the number 2 in there. So can you guys all see this? So instead of put x equals 3, I'm going to go back. And I'm going to say, look, let's put x equals 2 in there. If I put x equals 2 in there, then what do I get? This becomes 2 to the power of 3 minus 3 times 2. Does that equal 1? Let's see. 2 to the power of 3 is 8. 8 minus 3 times 2 is 6. And that equals 2. So that's much closer to 1. X equals 2 is much closer than x equals 3. Yeah, that was really, really far away. This is closer because when I put x equals 2, I get an answer of 2. And that's closer to 1. You see what's going on? So when they're saying find a solution, they want you to find a number that you can put in here to make it true, to make this equal to 1. This side, whatever I put into x, I should be able to make this side into 1. Right now, when I put a number into x, this side became 2. And 2 is still not equal to 1, but it's closer. So I keep on doing it. If I put a number in like 3, I realize that's too high. I need to put a lower number in. And I keep on putting numbers in until I get close to the answer I want. Does that make sense, guys?
Yeah.
Yeah. So this is what we say when we're talking about trial and error. We're trying to find a solution. This is one way to do it. You're going to learn a multitude of different ways to do it in a second. So let's put it on for you, Charlotte. Let me make it big. New share. Let's share the PowerPoint screen. And here. So the value of 1.9 was found using a graph. We can improve the accuracy of this answer by substituting 1.9 into the equation and noting whether it's too high or too low. What they're basically doing here is saying you have some use with graphs. Graphs can help us with this. We're going to look at how they can help us. But they said they found a value of 1.9 and they said that's close to the answer that they want. When they put 1.9 in here, let's look at what happens. Trial and improvement. So you set up a table. If I want to find the answer to something like this, I make a table. And I put in the value of x that I've got. I might put in x equals 3, x equals 4. I'll get a number. It might be too high. If my number's too high, I'll put a lower value in, x equals 2, as we done. If my number's still too high, I'll put an even lower value in, like x equals 1.9. And if I do that in my equation, my answer becomes 1.159, 3 decimal places. I need 3 decimals. What's the comment? Is that still too high or not? Is 1.159, which I get from this side, equal to 1?
No.
So my common is too high. So then I think, okay, maybe I should put in 1.8. If I put 1.8 in there, what happens? I want you guys to do this with me now. So if you've written a question, copy this table and let's start putting in values. Yeah, we're going to put 1.8 in. We're going to work that out on your calculator. And then we're going to carry on until we get a good answer. We've got 28 minutes left only. If any of you want another break at any time, let me know.
Wait, how did you get 1.155?
1.159 here.
Yeah, 1.59, yeah.
But what you do, you put 1.9 into where x should be on your calculator. So you do 1.9 cubed minus
Okay.
3 times 1.9.
Minus,
Got it?
yeah, yeah.
Marco, is it going okay?
Yeah.
Excellent. Have you done this before, trial and improvement, Marco?
No. Well, not with this topic.
Okay, cool. Yeah, hopefully by the time you go back to school, Marco, you'll have all of this ready and you'll be good with it. So what are you doing on the weekends now, Marco? Are you still like doing activity? You're not doing any more activities, are you? Like football and that?
No.
Oh, sorry to hear that.
It's at home.
At home, well, it must get boring.
Wait, 3x,
Yeah?
3 times 1.9.
Yeah.
Yeah, okay.
Okay.
I'll go it, I think.
0.432?
Or I got the answer.
You got that? That should be the answer you're getting.
Yeah, I got 0.42.
Perfect. Now, is that too high or too low?
Too low.
Too low. So now we know 1.9 is too high. We know 1.8 is too low. So someone just said it. Well done. You put something in between the two. Maybe 1.85. Because we know if something's too high and too low, the answer's in between them somewhere, isn't it? So now we've said the solution is between 1.8 and 1.9. We can test 1.85. Try that out, guys. This is long and boring in some ways, but it's just important to go through it once together. And then after that, it's okay because you've done it once. And then I can tick it off my list. You can tick it off your list as well. When you do 1.85, you get something like this. And you'll find, yeah, good, well done. You'll find it's too low. You guys are doing well. And so now you know the answer is between 1.85 and 1.9. Earlier we said 1.8 and 1.9. Now we've narrowed it down. So this is like an investigation. You're looking for clues. And as you look for more and more clues, you get closer and closer to catching the criminal. Yeah. Then we say 1.87. If we've done that, let's do this last one, 1.87. You'll find with 1.87, you should be getting something like this, which is getting very close to the right answer, but it's still a bit low. 0.92, we're close to the number 1 now, but it's not exactly 1. So again, we're a bit low. But what we know now is the answers between 1.87 and 1.9. Because 1.85 is too low, 1.87 is a bit higher, but that's still too low. Our answer is going to be between 1.87 and 1.9. We're getting more and more closer to where the correct answer is. Does that make sense, Hamza? Yeah? Okay, good. So 1.88, let's try. I'm not going to make you do 1.88. We can just copy the answer down for that one. We're getting an answer of 1.004. What about that, Jose? Is it too high or too low?
It's too high.
Too high, exactly. So look at what we've done. First, we had 1.9, too high. We said, okay, let's go lower, 1.8, too low. Then we realized the answer is between 1.9 and 1.8. We don't need to try 1.7. We don't need to try 1.6. As long as you know your answer is between two things, how do you know that? Because one's going to be too high and one's going to be too low. You can now get those two things. Now we look between these, 1.85, too low. 1.87, too low. 1.86 became too high. So now we've got too low and too high. Whenever you have too low and too high in between them, you'll have an answer. So the answer is going to be between 1.87 and 1.88. Does that make sense, guys?
Yeah.
Hamza, you said something, I can't hear you.
Yeah, but I was gonna say it's between those two.
Yeah, exactly. Does that make sense? How we're narrowing it down? So that's the trick to it. Yeah, good, well done. The trick is to find how we narrow it down. Now they want the answer to 3 decimal places. They want the solution to 3 decimal places. We're still at 2 decimal places, but now life's going to get a bit more not complicated, but it's going to get a bit more accurate. We know our answer is between 1.87 and 1.88. Okay, so the next, because it's between 1.87 and 1.88, we try what's in between them next, 1.875. We're getting to 3 decimal places now, guys. You see how that's happening? I think, just nod if you are. Yeah, good. Okay, so 1.875. Try this one, guys, as your last try, because we want to try a 3 decimal place one as well. Is it making sense, Marco?
Yeah.
Good. Zach, it looks like it's making sense to Zach as well. Good job, Zach. Good.
It's too low.
Yeah.
It's too low, exactly. So now your answer is going to be between 1.875 and 1.88. You see, we're getting it more and more accurate as time goes on. And eventually, what you'll find is your answer becomes more and more accurate. And in an exam, they want you to have some type of answer that's accurate. You're never going to get the right answer, an exactly accurate answer. But what they said, they wanted the solution to 3 decimal places. Yeah. So here we're going to get 1.000. When the first 3 decimal places are 0, it means your solution is correct to 3 decimal places. Do you guys get that?
Yeah.
So when they ask you for a solution to 3 decimal places, you get something like this. But it only comes after this trial and error you're seeing here. So guys, what you can do, just copy this table down as it is to see the journey of this number. So there you go. That's going to be your solution. Even though it's too high here still, we can see it's correct to 3 decimal places.
How many zeros does it need to have? What does it matter?
Yeah, that's a very good question. Because they said find the solution to 3 decimal places, in the solution you should have the first 3 after the number you want being 0.
Oh,
That's what they mean.
okay.
Did you get that? Good.
Yeah.
Excellent. So 19 minutes left. Good, we're almost there. Hopefully we can finish the PowerPoint of today. So next week we can practice. I'm going to send you some homework as well. So do it if you can. Okay, I think some of you guys are done. Can I move on?
Yeah.
Okay, cool. Now, what you're going to do, you're going to try. One sec. Oopsie daisy. Right, you're going to try this one, yeah? Okay. Can you see it, Marco?
Yeah.
Okay, well, the answer to two decimal places. Hamza, you okay? Yeah, you okay? Okay, cool. You guys can turn your cameras off if you want. You can leave them on. It's not a problem. So you're going to find the first number you want to put in maybe is, I don't know. Let's see. You try. You guys can try. Put a number in that you think might be correct. I've done the first two for you. So make a nice neat table, because as you copy out the answers later, when I give you the right answer, you'll need a table to put the right answers into.
Why does it say equals 0 at the top?
So they want you to put a number in here in X, which will make this thing go.
Oh,
yeah.
oh, to 0. Oh, they want.
Yeah.
Yeah. Okay.
Okay.
Yeah.
Now, don't worry if you guys don't get it right this time. This is a tricky one, and we're going to practice it as time goes on. But I'm going to put answers up as well. I think the way they're writing the answers isn't correct. This should be too high over here, to be honest, not too low. In fact, because we're running out of time, and this might take long, what we'll do, guys, my apologies, you practiced it, you understand it kind of. We'll do an exam question. This is going to take a long time, this one, and it's going to waste your time. So is that okay if we move on?
Yeah.
Okay, we're just going to move on, yeah? Otherwise, it's going to take too much of your time up. We'll do an exam question, which is better than this. But you guys are getting the idea of how to do it, right? Yeah, good. Okay. So rather than this, we'll do it through an exam question. Let's look at the next bit. Function notation and transforming graphs. What we'll do, let's look at some exam questions before we finish this lesson, just to make this useful. I'm going to pull out an exam question on the topic. Let me graphs. There's still a bit of stuff we have to learn on these graphs. Let me just check one thing before we carry on.
How we finished 5 minutes early.
It won't be right because your parents might not be happy about that. That's the only reason. Otherwise, I don't mind pace. It's because they're, you know. Let me show you one thing still. We are going to look at. Here we are. Okay. Now, before we go to the exam paper even actually, I want to do the last and most important bit of graphs. Can you guys see the PowerPoint?
Yeah.
Yeah? Okay. We're going to practice a lot. But before we practice, Do you guys remember when we done factorization? Yeah? Okay. Oh,
Yeah.
oh, hello, Jose, if I can see you now.
Yeah.
Nice room, bunk bed. Okay, good. Okay, anyway. So I want you guys to copy this title down here using the quadratic formula, but add to it using the quadratic formula with graphs. Yeah. Using the quadratic formula with graphs. Mark, are you okay?
Yeah.
Good. We're going to add our last bit onto graphs and we'll be ready to do exam questions after for next week, hopefully. Sure. So using the quadratic formula with graphs is your title. And underneath there you can write this. Any quadratic equation is of the form ax squared plus bx plus c equals 0. So any quadratic equation is of the form ax squared plus bx plus c is 0.
I remember doing this in school.
Yeah, you with me?
No, in school.
In school? Okay,
Yeah.
good. Do you remember it inside out or do you think a recap would help you?
Yeah, recap.
Okay, we're going to recap with graphs. So the next slide you see might not be connected to school. Let's have a look now. So you're just going to write this title down here using the quadratic formula with graphs. Write down this bit over here. Any quadratic equation of the is of the form ax squared plus bx plus c equals 0. And we're going to talk about that. So if we look back at our nice little drawing program I've got here. Can everyone see the whiteboard?
Yeah.
Yeah. So a quadratic equation looks like this. Let me just not write like a little baby. X squared plus bx plus c. That's what you call a quadratic equation. Why is it called a quadratic? Can anyone tell me that?
Got x squared.
Exactly. Anything which has an x squared in it is called your quadratic equation. Okay. So there might be an equation that looks like this: 3x squared plus 4x plus 9. And we might put this into it. Y equals, well, let's do it on this side actually. Y equals 3x squared plus 4x plus 9. We know now, because this equation has an x squared in it, in some way you can draw a graph of it. Because anything with x squared, you can make a graph. And the graph will look something like this. Maybe, yeah? Does that make sense?
Yeah.
So quadratic equations, which are of this form, because every quadratic equation kind of looks like that, can be made into a graph. Because you can make it into a graph, the numbers in the quadratic equation here are connected to what's going on in the graph. And you can use these numbers to help you work things out about the graph. If I know how to use these numbers, it can tell me a lot about this graph. What can it tell me? That's what we're going to look at next. In the next 10 minutes, which is our lesson time, we're going to finish this off, yeah? Can we see the PowerPoint?
Yeah.
Yeah, now hopefully we can. So let's look at how this works. Now, I'm going to skip all of this because we don't need it. What we do need is what's coming up in a few seconds with graphs. Blah, 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 blah. Aha. So write this down. Using b squared minus 4ac. Just the title. Using b squared minus 4ac. Okay. Now here. Your equation is y equals ax squared plus bx plus c. It's this thing over here, yeah, which I'm circling with my arrow. That equation will make three types of graphs. It might make a graph, they'll make three parabolas, yeah? It might make a parabola which crosses the x-axis. This is the x-axis. The line is crossing over into next territory and coming back, or into other territory. It's got two solutions. It just means it crosses the x-axis and it hits it at 2 points. This point over here and this point over here. Your graph might look like this, which is it just touches the x-axis. And because it touches it at one place, we say it's got one solution. It might also look like this, which is where it doesn't touch the x-axis. It doesn't touch it at all. And in this case, we say it has no solutions. Does that make sense?
Yeah.
Yeah. So what happens when you draw a graph? I'm going to explain it all to you. I'm going to explain everything to you. But first of all, we have to understand that we have three types of graphs. One that crosses the x-axis at 2 points, point A, point B. One that doesn't cross the x-axis just touches it, and it only meets at one point. One that's in the air floating, it doesn't touch it at all. These have solutions. Earlier, before we move on, let me just go back to the diagram. Yeah, what we said earlier was a graph can have a solution. A solution is where two lines cross each other. So for example, you might have a graph that looks like this, and there's a line and this line, and they cross each other here. Two solutions, right?
Yeah.
Yeah. We might also have a graph that looks like this, and my u crosses the x-axis. So my solution now becomes where it crosses this line, the x-axis line.
Yeah.
Wherever two graphs cross each other, whether it looks like that or looks like that, we have a solution. Does that make sense?
Yeah.
Yes, Zach? Okay.
Yeah.
Now, Marco, are you still with us?
Mm-hmm.
Good. So how do I know how many solutions it has? In this case, let's look at the case we're looking at now. We're looking at a situation where you don't have two lines crossing each other, but you have the curve crossing an axis. And because of that, we have a solution here and we have a solution here. We have one where a curve doesn't cross the x-axis, it only touches it. So we have a solution here. And we have a third situation where the curve floats. And so because it doesn't touch the x-axis, it has a solution here, but we're not interested in that. We're interested in solutions on the x-axis. It has 0 solutions on the x-axis. Does that make sense? Yeah, Zach?
Yeah.
So how do you know, if I just had the equation of a graph, there's a way I can tell just by using the equation. I don't even have to draw the graphs. If it's going to have 2 solutions, 1 solution, or no solutions. And how do I know it? I use these equations here. B squared minus 4ac is positive. We're going to talk about this in a second. B squared minus 4ac is 0. B squared minus 4ac is negative. What I want you guys to do is copy these 3 graphs down and copy everything in the box, including this b squared minus 4ac part. Then I'm going to explain to you how it works. Okay? So have a go at doing that. Have you seen this before, Zava?
Huh?
Have you seen this before?
Yeah.
Okay, good. So I'm going to explain it to you in a second. Marco, you copying?
Yeah.
Excellent. What beautiful technology. Makes life easy for us. Thank God. Okay. I'll give you guys another minute to copy. And then we'll talk about how this works, what it means. Okay. So once you guys have copied that, I think Zach's still copying, Hamza's still copying. Marco, you still copying? Marco? Marco? Marco has left the building, maybe. Okay. So let's look at this together now. Just give you guys another 30 seconds. I will look at it. Then we're going to kill our lesson in 3. Finish nearly. We're nearly finished. We're going to finish our lesson in a couple of minutes. It's 17:57. We'll finish by 6 o'clock. No problem. Okay. So let's have a look. If I draw a, if I go back to my little picture, smooth draw. Okay, new. No. Okay, so I've got a graph, I've got an equation, for example, y equals 3x squared plus 2x plus 4. And if you looked at what you wrote in your notes, it said b squared minus 4ac. And it says if it equals greater than 0, or if it equals less than 0, or if it equals 0. You have 3 things. If b squared minus 4ac is greater than 0, you have 2 solutions. Yeah, do you remember that from your notes, guys?
Yeah.
You just wrote, if it's less than 0, you have 1 solution. And if it equals 0, you have no solutions. No solution. Now, what 2 solutions means is basically a graph which crosses your axis in 2 places. What 1 solution means is a graph which basically touches, which you just, this is all the stuff you wrote just now. And what no solutions means is a graph which is floating. Okay, so let's look at this. This follows the pattern: ax squared plus bx plus c. What's a going to be here? A equals 3, b equals 2, c equals 4. Let's do this to it now. B squared minus 4ac. B squared is going to be 2 squared minus 4. Yeah, AC. A is 3, so times 3 times C. C here is 4 times 4. What do we get? 2 squared is going to give us 4. Minus this times this times this. Exactly. So minus 4 times 3 is minus 12. Minus 12 times 4 is minus 48. 4 minus 48. What does it give us? Minus 44. Is that less than 0 or greater than 0?
Less than 0.
Less than 0. So if b squared minus 4ac is less than 0, what do we have? A graph that
One,
looks like?
one solution.
Exactly. So it's going to touch your axis. Do you see how that's working?
Yeah.
That's all it is. You can use this equation with the rules to figure out how your graph's going to look. If it's going to cross, if it's going to touch, or if it's going to float. Make sense?
Yeah.
Is everything okay there?
Yeah.
Okay. So with that, I'm going to conclude today's lesson, inshallah. Well done, guys. I'm going to send you guys some homework related to this. Do it if you can. Okay. And next week we'll continue. All right?
Yeah.
Well
Assalamu
done.
Is there tuition tomorrow?
Huh?
Is there tuition tomorrow?
For science?
Yeah.
Yes, there'll be a science tuition. I'll let you know. If I cancel it, I'll let you know. I'm just going to say it up here. Okay? All right.
Bye, Huzifa.
Huh? What's
Bye
that?
to Huzifa. Bye to Huzifa.
All right. Marco?
Bloody Indian parents, man.
All right. Take it easy, guys, yeah? I'm going to,
Yeah.
if this is recording, I'm going to put the recording on YouTube so you can watch it again. I'm also going to email you guys by tonight, hopefully, the PowerPoint on the lesson. So you can look at the PowerPoint as well, yeah?
Okay.
Okay. Take care, guys. Assalamu alaikum.
Wa alaikum salam.
Good.